Morning, AP Calculus. It's been kind of lonely here without everybody here, but here I am at school, and I'm going to give you a video lesson. Hopefully, this will work out for you. So bear with me, because I'm kind of new at this, and I'm just going to go right to the notes here. Okay, so we have day number 127. 319, area between curves. So you guys are going to be doing this on Khan Academy. The notes I'm going to give you are a little bit more in-depth than what Khan does. This is what we need to do for AP Calculus. Find the area between a curve and the x-axis. That's our focus for today. Pretty soon we're going to be doing two curves, but I want you to look at this one today. Here's model example number one. We're going to find the area between a function f of x equals this cubic equation and the x-axis on this interval from 0 to 2. Let's just see what we have here for this. And so I think a calculator is good to do this, and I just graph this function, and this is what it looks like. Okay, that's 0 to 2. It crosses this. It looks like it crosses it too. So I'm just going to draw a picture of that graph here. 1, 2 starts here, and it looks like about at 1 it crosses, and then like 1, 2, it like kind of does this. Okay, now we're talking about area, so we're talking about positive areas. So I'm going to look at the area here under the curve, this one, and this one. Now, I want to count those as positive. So if I just took my definite integral, that won't equal the area under the curve. And just to see that, if I take the integral from, say, 0 to 2 of f of x dx, I can do that on a calculator. I could say, what is that area? So I'm going to calculate the integral, lower limit 0, enter, upper limit 2, enter, and I've got this, and what does it say? Well, what the heck is that? That means that's times 10 to the negative 14th, so that's moving the decimal left 14 places. So that's actually the calculator's way of saying that's close to 0, but I made an error. So it's basically 0. So actually those two areas are equal, and so they calculate the sum as being 0. So it counts that as positive and that as negative. We don't want that. That equals 0. No, it's not the area between the curves. That's the definite integral. We call this the definite integral. Sometimes that's important, but today we're going to try to find the area between the curve and the x-axis. So really, I want to find the positive area. So the area between curve and x-axis. What I would say, that would be given by the integral from 0 to the intersection point. Now, I'm thinking the intersection point is at 1. If I wanted to calculate that, I'm just going to say regraph that. I better do this. Oops. I'm going to, calculate 0, 2, and then I'm going to go left bound, enter, right bound, enter. So I'm looking in that little area, guess, enter, and it tells me that there's a 0, y equals 0 when x is 1. So that is definitely 1. So that's going to be the breaking point. So I'm going to do 0 to 1, do this one of f of x dx. And then what I would do for the other function is I would subtract it off. So minus the integral from 1 to 2 of f of x dx. And so this should give me a positive area here, and the negative double negative over here should give me another positive. So that's what I'm going to do. So let's go ahead and do this and do it by hand. So this is it. Well, I'm like doing the same things I normally do in class, like not scrolling. Anyway, this first one, it's going to be the integral from 0 to 1 of x cubed minus 3x squared plus 2 dx, and minus the integral from 1 to 2 of the same thing, x cubed minus 3x squared plus 2 dx. So we do this and we have x cubed over 4 minus, that's x cubed over 3, so I'm just going to do x cubed plus 2x evaluated from 0 to 1 minus, and then let's do this other one, same thing, x cubed, no, that's x to the fourth, sorry, fourth over 4 minus x cubed plus 2x evaluated from 1 to 2. So plug in 1 here and we get 1/4 minus 1 plus 2. And then subtract the 0 minus the 0 for that part. Minus, and then let's do it for this one over here. Plug in 2 to the 4th power is 16 fourths minus 2 cubed is 8 plus 4 minus, running out of paper, let's see, 1/4 minus 1 plus 2x plus 2. That's 1 1/4. It's the same as that one. So, not scrolling again. Okay, so now I have, that adds up to 1 1/4. I'm just going to put 1.25 for that one. And this one ends up being, that's 4, that's 0. And that's 1.25 again. Oh, minus negative 1.25. Oh yeah, with those two were the same, like they were the same, so that I add them, that's 2.5. So that's it, 2.5. I should get 2.5. Okay, so that's what we did. We found the area between the that curve and the x-axis. Now, I guess we should probably think about doing that on the calculator because, you know, we got a calculator. So how would we do that? Well, we could set that up, but there's actually a really good way to do this. And that is if we take the absolute value of the function. So I set this up in line 2, I did the absolute value of y1. And I'm just going to turn that on and turn this one off. And I'm going to graph this and see what happens when it hits there. Oh, it counts that side as positive. So now I'm going to calculate the integral, that's 7, from 0 to 2. Oh, that's 2.5. Okay, good. All right, we did that right. So there it is on the calculator. So I'm going to say that this area between the two curves, or between, oh my gosh, curve and the x-axis could also be calculated by taking the integral from 0 to 2 of the absolute value of f of x dx. And that will always be true. That will always be true. If I just take the absolute value, I don't have to find the intersection point and split it up. But not all the time will you have a calculator. This is only really handy if you have a calculator. Let's look at another problem here. Oh yeah, I have it here. Find the area between f of x equals x squared minus 4 and the x-axis. So we're going to do this one without a calculator. Let's take a look at this. This time it does not give me the endpoints, but we might notice that this is a parabola. A parabola x squared goes this way, it's minus 4, so it's down here, so it's the parabola that's shifted down 4. And there are two zeros, and that is going to be a positive area. So the first thing to do here is to note the zeros of the function. What makes the y-coordinate 0 in these cases? Normally what you would do is you would set this equal to 0. This is, you would find the zeros. Find the zeros by setting that equal to 0. And you could factor this. 0 equals x minus 2 times x plus 2. So x equals 2 and negative 2. And that gives me my 2 zeros. So I can set up my area that I want. It's going to be the integral from negative 2 to 2 of f of x dx, although that's going to give me a negative area, so let's just take the negative of that. Okay, now I'm just going to calculate that integral, so that equals negative the integral from negative 2 to 2, scroll up, of x squared minus 4 dx. So I'm going to say that that is x cubed over 3 minus 4x evaluated from negative 2 to 2. Plug that in, I get negative, let's do this, 8/3 minus 8 minus, plug in negative 2, that would be negative 8/3 plus 8. Being careful with those negatives, and we get negative, that's the outside negative, we have 8/3 minus 8 plus 8/3 minus 8. 8/3 plus 8/3 is 16/3. Minus 16. That's 16/3 minus 48/3, getting a common denominator. That's 32. Am I right? 32. Negative 32/3. So that's 32/3. Okay, well, good thing we had the negative in there, or we would have had a negative number at the end. We had 32/3, so that's our area between our function and the x-axis. In this case, it didn't tell us what the endpoints were. We had to find those by solving that equation, setting f of x equal to 0, and we got it. I think that's about it. I mean, I suppose I could do this on the calculator, but I'll leave that for you to do. You could try to set this one up on the calculator. Let me just make a note. For the calculator, I could just do the area equals the integral from negative 2 to 2 of the absolute value of f of x dx, and I could just do that. It's going to give me the positive answer. To review really quick, the way that is really handy is when our function crosses the x-axis and I don't really know where. So this will just kind of solve that problem for us by making this part right here a positive area. Anyway, I hope that helps. Let me know. I'll see if I can post this. Uh-oh, I'm already too long.